But Belinda and I are going to do a bit of a tag team here, I guess, and Belinda was very much involved with the sort of infection control side of things, and I feel slightly responsible because I think it was a little bit my fault this whole thing happened, but I'll come clean. So, in fact, I from time to time do a weekly stint at the PA lab, and this was my week at that point, and we'd noticed on the screening bench, so I remember we were talking earlier about how we do rectal screening swabs for patients to look to see whether they're colonised in their gastrointestinal tract with these multi-resistant organisms, and particularly these multi-resistant gram-negatives. And we'd noticed there were 3 patients who were all on the same ward, the infectious disease ward. Now that is not totally unusual because often patients that are colonised with resistant things get transferred to that ward for isolation purposes. But all these strains had a fairly unusual antibiogram, and the thing that pricked my attention was that the MIC, so remember this is sort of a measure of how resistant these organisms are to an antibiotic, to this drug called meropenem, which is usually a very, very effective antibiotic against these strains, was actually on the relative high side. So in fact, if it was 2 or above 2, we would actually call this a resistant or non-susceptible strain. Now that for an E. coli is a very, very high number. Usually this would be orders of magnitude lower than that. So this is very unusual for your average ESBL E. coli. So that seemed a little bit strange to me. And they had this unusual antibiogram where they were resistant to things like third-generation cephalosporins, piperacillin tazobactam, and quinolones, which by itself is not that unusual for these strains. But they were quite sensitive to aminoglycosides and trimethoprim sulfamethoxazole. And in fact, that pattern is not something we tend to see, certainly not looking back in Queensland. So, in fact, we'll talk about exactly what we did about that, but certainly this pattern was not something we tended to see. As I said, if you look at the distribution of MICs for ESBL, E. coli in our part of the world, only a tiny number of those will have MICs even approaching 1. The vast majority of these will be like, 0.02 or below. So that's why, a little flag in your mind going, something a bit strange is going on. So, you're in the laboratory, you're sitting there with the infection control nurse at your side, you think you've got 3 slightly odd-looking ESBL E. coli in colonised patients. So I guess the question is, any suggestions of what might you do next? Just ignore it, hope it goes away, that's one option. Or what could you do? What are some simple first steps without sort of initiating a huge kind of major investigation? Are there some simple things you could do in the first instance? Let's. Yeah. So at this point, these are actually in they're all inside rooms at this point. So let's say, what about from the laboratory point of view? So anyone from any lab-minded people here? Michael, what would you do? Yeah. And any other sort of... Yeah. And any other lab testing you do on the bench, let's say? Yeah, you do a carbapenem P. Hannah's put a vote in for the Hodge test. Anyone else a fan of the Hodge test? Yeah, so Hodge test, it's sort of gone a bit out of favour actually. It's not bad for KPC but it's not so brilliant for other things. But yeah, so there are a variety of phenotypic tests one can do, and in fact that's kind of what we sort of did. Now, up until this point, we tended to use what's called the clinical breakpoint. So without delving too much into the sort of minutiae of these things, we talked earlier about how we have international standards that kind of set some definition of when an MIC becomes into a resistant range or it's in a susceptible range. And these are based on a suspected clinical response. So we think that if an organism has an MIC up to 2, they should respond to that drug in appropriate normal dosing under normal circumstances. So this is called the clinical breakpoint for that MIC, for that organism. And in fact, for meropenem, anything above 2 will flag up as being a resistant organism. But that's a clinical question. often you can have resistance mechanisms. There can be something about that organism that's able to resist the antibiotic. It hasn't pushed it to a degree that it's fully resistant and won't respond to that drug, but it's got a resistance mechanism there that it's telling you there's something not quite right about these organisms. And this is where we talk about what's called the ECOF, or the epidemiological cutoff, or sometimes called the sort of wild type distribution. If you took 1,000 organisms from nature, you would expect them to have an MIC distribution that sort of usually approximates some kind of normal curve. And, the upper limit of that should be, where you would expect the upper range of those MICs to be. And if you have an organism that's sitting far outside of that distribution, then there's something odd about that organism. It may not be at the clinical breakpoint, but it's above the kind of MICs that you would expect for a normal organism. So that's where these organisms were sitting. It was in this sort of unusual grey zone. There's a variety of different tests that we can do. So we talked earlier about the CARBA-NP test. So this detects carbapenemase. We check the MIC with the different methods. So there's a thing called e-test, which is, I guess, our standard way of doing confirmation of an MIC value. And we also use some of these chromogenic media. So these are selective agar plates that only grow the kind of organisms that you want. They only look for resistant strains, and they'll have some sort of colour change, which will give you an idea of what species they are. And in fact, 2 of these isolates had this beta-carba positivity, which is, again, suggestive of a carbapenemase production, but one of them didn't. The MIC, when we tested according to using an e-test, was, again, not that high, so this would be clinically susceptible, but again, it's higher than you would expect for a normal E. coli. And more importantly, they all grew on this chromogenic media, and the way that the commercial product that we use has 2 halves to it. So one half detects a broad range of carbapenemases, and one half detects these difficult carbapenemases called oxotype carbapenemases. Now, there are hundreds of different types of oxes, but the oxotypes that we really worry about in our common gram-negatives like E. coli, Klebsiella, are these OXA48-like family. So there are a group of different oxas that are all quite similarly related. They're relatively weak carbapenemases, so they're quite hard to detect. But because they're hard to detect, they slip under the radar, and they can easily cause outbreaks. And combined with other mutations, like a loss in porin, they can actually lead to very high-level resistance to antibiotics. So they sort of spread under the radar, and then they can pop up and cause a problem. And in fact, they've spread really rapidly from the Middle East, Mediterranean, right across the world in a very short period of time. So they're sort of a looming problem for all of this. So we were very suspicious from the phenotypic testing that these had an oxotype carbapenemase, and in fact luckily we have a PCR available, so a simple single gene detection assay that's easy to do, and that confirmed the presence of an OXA48-like carbapenemase. So at that point we know we have 3 strains that all carry this slightly unusual gene. And OXA48s are not commonly seen in Australia, and particularly almost never without some kind of travel or healthcare exposure overseas. So to pick this up in Australia is essentially, we had never seen this before. So that immediately is alerting you to something strange is going on. Over the next few days, I think there might have been a little bit of additional screening that was prompted at that point. There were 3 more positives, 2 from the ID ward that the original cases were found from, but also 1 popped up in the intensive care. This is one of my favourite. This film actually made me want to do infectious diseases as a young lad. I remember watching this slightly inebriated in Mexico for some reason, and here I am. Yeah, strangely. So we think there's something going on. We know we now have 6 or so potential CPE cases. We know that at least 3 of these have an OXA48 gene. The others are looking suspicious. Rather than just leaping into sequencing, what are the other things we could do from an infection control point of view? So Trish, let's say this was, you just got over crab. You just think you're going to have a week off, and then this comes across your table. We call you up and say this is happening. What would you do?
Screening, start looking at the environment.
Yep. Are there some simple things you could do just from, without initiating any dramas, just on your desk in your office, things you could do there and then?
Oh, right, yes. Well, our system and obviously if there's any other isolates just in part.
Yeah. Yeah. So this was actually, I think, probably one of the first things we did. I think Naomi spent a lot of time trawling through Oz Lab. But one thing that really struck us was that slightly unusual antibiogram. And in fact, that was quite a useful little way into the problem, because it wasn't something we thought we'd see very often, but we wanted to actually prove that. So we looked back over I think it was the prior 6 months or so, and there were over 1,000 E. coli, ESBL or CPE phenotypes that have been described all across Queensland in all public hospitals. But there were only 8 that had that particular antibiogram, so it was extremely unusual. And in fact, only 3 of those were in the PA within the preceding few weeks. So immediately that kind of narrows it down to okay, we probably know where we might start to look. So I think, again, and what I'm making the point is that, rather than just leaping into sequencing, there's a few things you can do first, just basic kind of simple epidemiological investigations that aren't particularly labour-intensive or complicated, that might sort of point you in some direction. So in fact, Belinda, do you want to talk about these cases? You probably know these even better than anyone.
So we thank Patrick for this, and we also thank Carly for this, because Carly just moved into our multi-resistant organism portfolio, and Naomi had a little bit to do with it as well. So when we look back in retrospect, we actually identified this little gentleman, a 94-year-old fellow, that was transferred to us via a commercial airline from Vietnam. So he was on holidays with his family and had a fall and had a fractured noff, and he was managed in a hospital in Vietnam for about 8 weeks, non-surgical management. He had lots of skin tears and pressure areas and all of those things. So he should have flagged on transfer from the international airport. I don't know why they didn't bring him to the Royal. I'm not sure what happened. But, in interest, just as a point of interest too, I suppose, Crispin made a note before about the fact PA has 7 staff. I think you guys were sitting at, was it 8.4? Just putting that out there just as a note of contention. But anyway, this fellow got off the commercial flight with documentation written in Vietnamese from the hospital. His family then put him in an ambulance, and for some reason he ended up at our place. Came through our emergency department, which is great, was identified as having international healthcare contact, was screened in the emergency department for multi-resistant gram-negatives, VRE and MRSA, as per our routine screening policy. His swabs were poorly labelled, so when they hit the laboratory they were actually no tested, which was a little bit of a shame. And normally what would happen is, or the process, I suppose, is that the person who admits the patient will let infection control know we've got a patient that's come through as an international transfer. None of that happened. So when your processes work, they work well. When they don't work, it turns into a reasonably large outbreak. So this particular patient, he was sick. He was in a ward bed for a good period of time, in isolation, waiting for the swabs to come back that never made it to being tested, and then was subsequently moved into a 4-bedded bay. And because of his injuries and the nature of the beast being PA, he got moved around a number of times. So he did, as Patrick suggested, have an ESBL E. coli isolated, which was exactly the same antibiogram, and the Mero MIC was 1. And of course, for us, if we're doing the laboratory round with the staff, it's sensitive, so it wouldn't have flagged with us until Patrick came along and found all the others. So that was challenging. And we don't like to say that orthopaedic surgeons don't wash their hands, but perhaps orthopaedic surgeons don't necessarily wash their hands. So our case 2 was another patient who was admitted through our emergency department about 4 weeks later into the general medicine area, where this patient also was with our index patient and had orthopaedic involvement. There was a little bit of overlap with case 1 by 8 days. And this patient had a clinical isolate, which was a urine specimen, was collected, looked exactly the same, although the MIC was 0.25, I think, at that point in time. So you can see we're sort of starting to build a picture. And then case 3 was a spinal patient who had a nasty spinal injury, orthopaedic involvement as well. No case overlap with 1 and 2. And it was about a month later, and again another positive urine with similar or exactly the same E-biogram, and then subsequently marrow MIC of 0.25. So all of a sudden we had our 3 cases, infection control were actively looking at what's going on, what do we need to do. So I guess when you think about that, you know, would you use sequencing at that time if you had access to sequencing? What do people think? Is that something you'd go, alarm bells ringing? It doesn't kind of fit the normal laboratory process, but certainly from an infection control perspective, we can see something's happening. So would people jump to, yeah, you'd use the technology if you had it? Why? Anyone?
You don't use it.
Because we can.
Not become problem.
Because we can. So I think if you have a little bit of a chat, there's a little handout in your bits, and then we'll have a bit more of a chat. So you've only got a couple of minutes to do that. Take the time.
It's not detailed in there, is it?
No. Just scroll down. So I think it's you now on the sequence. As a do
Talking positive.
That's how I like to say it's ridiculous, but it's
All right, everyone. Okay. Oh, everyone's had too busy chatting. So
we might hold court again for a moment. Excellent. There we go.
So Anna was looking very animated in the corner, holding forth. Tell us what you would do, Anna. You know, what would be your next steps?
Well, we were discussing, I guess, the original brilliance in the technique and the fact that not everybody would have. And I guess I was also talking about how
You'll go far in life. Yeah.
other laboratories or practices, whether through work or other things, it might be used. And obviously, we're also in a really privileged position at the moment with the concept of science and the funding that's available. We don't necessarily have to prove that there will definitely be clinical or infection control outbreaks. We do have to be the luxury of consider interesting as well. And so while we know that this is a carbonated producing isolate with an odd antibiogram and we're getting some MICs that are very low, we certainly would flag that in our position as saying interesting that sequence. There might be other institutions and organizations less budget that may not have proceeded to that.
Yeah, and look, I think, and these are why these strains are such a nightmare, because they're easy to just overlook.
Yeah.
They're not wildly exciting. Some of them are quite sensitive to meropenem. But we know that once they kind of get out in the wild, it's very hard to sort of rein them back in. And you can see how these could quite easily. And I think the thing to me that really struck out was like, well, we've got potentially a number of patients that have become colonised in quite a short period of time. So this has happened over a number of just a few weeks. So, you know, whatever's going on is accelerating at a fair pace, and we're probably only seeing like the tip of the iceberg, as we'll see. So yes, it would be nice to go, oh, well, it's maybe not such a big deal. That might come back to bite you if you let it fester for too long. So that was my justification for kind of getting a bit more excited at the time, rightly or wrongly. And I guess we had the technology available, so, you know, and I guess the question was, you know, again, are these truly related? They look like they are, but you guess you want to kind of nail that down. Will it give us any kind of ideas about the transmission related to the earlier patients, you know, confirming exactly, you know, what we're finding in terms of resistance? So that's kind of where we were thinking from. Now, in terms of technology, we actually use both Illumina and MinION in this case. Now, not that we had to, but we had that available to us. So I remember talking about earlier, so Illumina is the sort of workhorse sequencing instrument that I guess the vast majority of microbial sequencing is done these days. It's reliable, you get good data out of it, but you get these quite short reads, so you don't really get a complete genome. You get a kind of a pretty good kind of representation of the whole genome, but there are certain gaps and there are certain aspects of the genome that are hard to resolve, like repeated sequences, or if you can't necessarily say exactly where certain genes may be located in the genome, you may not be able to resolve plasmids or other mobile genetic elements. So it gives you a pretty good idea, but it doesn't tell you everything that you might want to know. And sometimes what you can do is then use the long reads from the MinION or any other sort of long read device, but MinION is particularly attractive because it's, you know, it's fairly simple and quick to do. And we thought what you could do is then you use the long reads as a kind of, you basically scaffold your short reads on those long reads and kind of then place your short reads into a better context. And that way, particularly, it'll help you understand things like plasmids. So if you have, we wanted to know, okay, we've got this potential oxa-type carbapenemase, but is it sitting on a plasmid? Is this something that's going to be very easy to spread? You know, those sort of questions can really be resolved better with that sort of sequencing approach. So what we did is we took 6 of those E. coli that we had in the lab at that time. Now, some of those very earlier strains, just to point out, because they were a few weeks ago and we just thought they were urines or swabs, had been chucked away, so we didn't have those available, but we had 6 going back in the more recent past. They all went for Illumina sequencing. And then we took 3 representatives from each of the 3 different hospitals that had been involved with at that time and sequenced them with the nanopore. And interestingly, we also included one strain that there was one patient at QE2 hospital who'd actually had treatment with meropenem, and their strain was highly resistant to meropenem. So the MIC had dropped from like nothing to greater than 32. And this is the point we're sort of making, in that those genes can kind of spread under the radar, but you expose these organisms to antibiotic and they can quite quickly become highly, highly resistant. So you can imagine if that was a critical infection, that could spell a real disaster for the patient. And I guess we're very interested, you know, what had happened to that strain to account for that increasing MIC. And I guess the sort of headline result from all of this is that, you know, they all belong to this sequence type 38. So again, we all know they're in the broad clonal group, that they all sit together. And more importantly, there were actually only 4 core genome SNPs apart. So these were all very closely related. And in fact, as you can see, you've seen a few of these plots that Brian puts together. All of these strains here are essentially identical at the core genome level. There's one here that has just accumulated 1 SNP, and one here that's accumulated 4 SNPs, but this was actually the highly resistant strains. And this is the one with a very high meropenem MIC. And in fact, these were mutations in some of the outer membrane proteins, these OMPs. And these actually, the antibiotics have to get into the periplasmic space through these channels, and if you lose them or you mutate them in some way, the antibiotics actually can't get into the cell to act where they're supposed to act. And that's quite a common way that these strains can kind of develop high-level resistance in combination with existing beta-lactamases. So that was quite a sort of nice representation, of sort of an early snapshot of what was really going on with these strains. We knew clearly that we had very closely related strains. This clearly was an outbreak, and also we got some indication as to what was happening at a resistance level. I probably won't go into, we've talked about nanopore earlier, so I'll sort of skip over that. Remember, we sort of said we also wanted to understand a little bit more about the plasmids and the antibiotic resistance genes. And again, what we found was very interesting because we had both an ESBL gene. So remember that these strains had originally been reported as an E. coli ESBL, which unfortunately these days are very, very common. And they all had this CTXM15, which is probably one of the most common types of ESBL genes that we see. But what was interesting is, in fact, the CTXM had incorporated itself within the chromosome. So normally these sit on plasmids and are sort of highly mobile, but this had actually managed to sort of wheedle its way into the bacterial genome. So once it's in the genome, it's essentially a little more stable, which was an unusual finding. But also we found that it wasn't actually an OXA48 carpenamase. Remember, the OXA48 is a family of carpenamases, so this was a relative called OXA181, which again is so as one might have expected. But this was sitting on an actual plasmid, so this was one of these mobile genetic elements, and this time called INC-X3. So we sort of got a pretty good idea of exactly where these genes were sitting, and we'll talk a little bit later about how that actually helped us again understand how these strains were transmitting in the hospital. So we've talked a bit about what OXA181 is. So these are what are called class D beta-lactamases. They're a bit of a pain because they're not very well inhibited by beta-lactamase inhibitors like tazobactam or clavulanate. And as I said, they're often called the phantom menace. It's a sort of nickname that we often give them. The other thing you can do is when you're looking at the plasmid, you can compare them to other known plasmids. So we were able to reconstruct that entire INC-X3 plasmid that was carrying this gene. And then you can compare them to other plasmids that have been described in the sort of international databases. For what it's worth, this plasmid has also turned up in China, Switzerland, and the Czech Republic. Make of that what you will. But again, it sort of shows that you have sort of parallel, you have to understand these organisms in different ways. There's a sort of clonal spread, where has this organism come from, but also where have the plasmids come from. And that can obviously be very hard to try and tease apart. But what was really useful is, remember, the first case that we suspected, at least on an epidemiological basis, had come from Vietnam. And what we were able to do is take our sequences and place them in an international context. So see, where does this fit in terms of the international databases? And interestingly, the closest previously sequenced genome of this ST38 E. coli was a strain from Vietnam. So again, it sort of doesn't prove it entirely, but it certainly would be very consistent with our story, our hypothesis that this had been introduced from that patient who'd been hospitalized in Vietnam. So we have that sequencing data. We know that these strains are very closely related. We know this is definitely an OXA181 that's sitting on a plasmid. It also has an ESBL in the chromosome, for what it's worth. You have these results. What would you do? What would you're in charge of the infection control team. What do you take as your next step? So we'll probably stop there for a second, let you talk amongst yourselves.
Yep. Alright guys, so what are you going to do at this point? We might start with Jackie's table up the back. What are you guys going to do? How are you going to respond? You're going to screen? Jackie's happy to take many screening swabs in the lab. Just call ahead. Bring ahead, let them know. Excellent. Marky, what are you guys going to do? Sorry. What were you guys going to do at this point? Now you've got the results. Screen the whole hospital. How many beds is Marga? The screening of the whole space. So this is the adults. So we're screening the adults. Yep. Excellent. Perfect. Oh, wait. You guys haven't said much, have you? What are you guys going to do? Oh, what are you going to do? What are you going to do with the kiddies in this space?
Isolate.
Yep.
Bring everything. Swab everything.
Yep. Okay, so your basic infection control principles and practices come into this space, yeah? So you're going to screen, pardon? Let your neighbours, well, we did that. You might remember we let the whole world know. It was very bad. I think Trish was talking this morning about reputation, and I think reputation for PA was somewhere down here already, and then we went even further down, and I think, but that's okay, but you have to do that, don't you? Because I guess the big hospitals, we share the love. We certainly move the patients around, and when there's lots of patient flow pressures and there's lots of bed pressures across the whole southeast corner, then it can potentially get really ugly really quickly.
On that point, do you ever get pressure from executive comms to make this stuff known?
No.
So they don't push back against
No. I don't know whether we're special, but certainly not. So we have a really good relationship with our exec, and that's always been the case, and we're a very well-established program. So I suppose when we identify that there's an issue, we have the conversations with the people that we need to have the conversations with to let them know. Media briefing point, as Trish said, you always have that on hand because you've got to look at the career mail test, which is ugly at the best of times, but no pushback at all. And I think, Graham, correct me if I'm wrong, but we were probably one of the first states to actually share what was happening in Queensland with the rest of the pathology routes, because I know a few years ago there was an issue in Victoria with KPC, and I don't know that anyone found out about it for quite some time, so it was really important to share that information. That's a fair comment.
Right. The other thing was, because it had a very specific phenotype, that went to all the labs in Queensland, public and private, so everyone was a little help.
Yeah.
And of course it was pretty trouble for other states as well.
Certainly that kind of communication with protective measures.
Oh, absolutely. PA's a dirty, dirty place. Everyone was, nobody accepted a patient.
Across the river.
Have they been screened? When were they screened? Do we need to take them? We'll screen them as soon as they get there. So that caused significant patient flow issues as well, because we wanted people to screen the patients if we hadn't already screened them. But there wasn't many patients left in the hospital over that 8-week time frame that we didn't actually screen. So this is a Gantt chart. So like Trisha's scroll this morning, Anna will remember the old days in infection control where we used to sticky tape all the pieces of paper together to get the big picture. And this was a chart that was made by Naomi where we actually looked at the patient flow component. So where was the patient? And automation of this particular document will be fantastic, and I'm sure we will get that eventually, won't we, Brian? Which is important. But we looked at colour coding things so we knew where the patients were, where had they been, to see if we could kind of capture what was happening and then target our responses to that. So our targeted responses were obvious things that we always do. Transmission-based precautions, so plastic aprons, gloves, enhanced hand hygiene. We shouldn't have to say enhanced hand hygiene, but you have to. You have to get out there with the cattle prod or the taser, whatever is your chosen implement, to try to get people to do the right thing. We had a big, big focus on hand hygiene. And I think over a period of time at our place, nails had crept in a little bit, you know, watches, jewellery, I don't know, every man and his dog had got engaged, so there was lots of beautiful big blingy rings and those types of things. So we had a big focus in that space. And I think because we had such a good relationship with our exec, we had those conversations. And our hand hygiene compliance at PA sits at around 78 to 82%. And some of the areas where we were seeing transmission were at that close to 80%, and some certainly weren't. And I think if I target my orthopaedic colleagues, which will probably get me into trouble at some point in time, but their hand hygiene compliance was pretty suboptimal. So, and they knew that, so we were having conversations at that time. But what we actually did do was use an outbreak as an opportunity. So it's terrible, turns your hair grey, makes you feel sick, you eat lots of cake because you never get lunch, you just nibble as you go. But certainly we used it as an opportunity. We used it as an opportunity to drive the infection control agenda. And at that point it was round managing medical staff, so for our medical colleagues in the room who always roll their sleeves up and never have their watches on in the clinical unit and adhere to hand hygiene, that's fantastic, but that's not the norm. ID physicians are great, others aren't. But certainly what we were seeing was lots of doctors with beautifully pressed sleeves, with gorgeous cufflinks, that would wash their fingertips. So when we were wandering around and having a conversation, and at one point, which you'll see in a minute, we had 3 wards closed. The impact of having wards closed is significant in a big hospital like ours, where we sit at about 110% occupancy most of the time. And, you know, we were wandering around having conversations, talking to patients, doing environmental sampling, looking at what was happening and getting out on the floor, because that's what you do in this sort of situation. And we were seeing really terrible practice. And I walked out of a room after talking to a patient to a huddle of a medical officer, a very senior medical officer, having an argument with a very senior nurse, because he refused to roll his sleeves up, refused to put a plastic apron on, and refused to clean his hands. So I was talking to a patient about something, I think they might have been in New Iceland actually, and about moving them to the infectious diseases ward. I wandered out, derobed to take my PPE off and was washing my hands at the sink. And then I hear from the corner, oh, here's infection control, they'll sort this out. That's who I am, infection control. So I wandered over not knowing the interaction that I was going to then become engaged in. And that interaction was very senior staff yelling at each other inappropriately and having an argument about why this doctor shouldn't have to wash his hands and roll his sleeves up. And his wife bought him that watch for his birthday. So essentially the conversation then went around and round in circles, and I didn't know exactly what was going on to start with, and I introduced myself as, hi, I'm Ben from Infection Control. You know, what can I help you with? And most people know who I am, which is okay, and sometimes not, but this argument then, and I just said, look, I'm really sorry, but we're in the middle of an outbreak. You need to roll your sleeves up. You can't wash your hands. You need to take your watch off and pop it in your pocket. And that's the end of it. So then I got yelled at by the doctor. And then I was running late for a meeting with the Chief Medical Officer for the hospital. So I rock up late to my meeting, and I get the frown from Jeffrey Playford as my director, "Bin, you're late." And it's like, and then I told him why I was late, and then in the middle of the meeting he said, "Oh, Bin, do you want to tell," Stephen Eyre was our executive officer at that point, "do you want to tell Stephen why you're late?" I was like, "Sure, I've just been abused in the ward." But from that moment, what then happened was a directive went out under the Chief Medical Officer for the hospital and the Chief Nurse of the hospital to say anyone who failed to comply with the infection control procedures and precautions, regardless, would need to provide a police explain as to why they should keep their job. So you've all read the papers from the US saying this is what you need to do. You need to take the big stick approach. We don't do that well in infection control. We might pretend to be the dog at the bone kind of thing, but we don't do that very well. And subsequently from that, we had this very, very senior consultant who's been at the hospital for longer than I have, and I've been in the hospital for 20 years, had a police explain why he should lose his job and have his employment terminated. That got around really quickly. And then there were no nails, there were no watches, everyone was rolling their sleeves up. The jewellery was staying at home. So I think you need to use an outbreak as an opportunity every single time as best you can. And we had union involvement then, because how dare we say that someone might lose their job if they don't wash their hands or comply with infection control precautions. And that was challenging, but certainly it worked. So in terms of other things we did, we enhanced our environmental hygiene. Our environmental cleaning at that point in time wasn't too bad, but certainly everything can always do with a bit of an improvement. We looked at screening, just infectious diseases ward and ICU, and then subsequently pretty much screened the whole hospital. Lots of ward closures, lots of swabs to the lab, lots of support by the lab, which was delightful. And we did lots of overtime. We focused on the key components of infection prevention and control, and it's really about the right thing every time for every single patient. So clean hands save lives, we know that. You'll see your infection control team wearing really daggy t-shirts that tell you that. But your 5 moments of hand hygiene are key. It doesn't matter if you know the moments or not, it's really about cleaning your hands before you touch the patient and when you're finished. Environmental hygiene became really, really key, but we really did focus at the first point on our general hygiene practices of the staff because we knew it was our opportunity. So this is our poster boy for our Bare Below the Elbows campaign at PA. We don't have paper charts anymore, we now carry a WOW instead, so a medical record on wheels being a computer. But certainly the rules are the rules, and this is what we kept with. And I think it worked quite well. And it seemed to be interesting because we didn't see lots of other organisms transmitting around whilst we had our outbreak, which surprised us given that we were putting all of our focus on the one thing. But we were also focusing on hygiene in general, cleaning, all of that sort of stuff, so it had a big flow-on effect. The collection of rectal swabs was quite interesting. So how many in the room are nurses? Okay, so a rectal swab, it's pretty self-explanatory, isn't it? Goes into the rectum.
No.
Perianal swab, yeah.
Wave it around.
Wave it in the air. Air swing. So we have a rule that says that, patients should not be given the swab to collect their own specimen. Many patients are handed that swab stick and asked to collect their own specimen. And that is a challenge. Because, people aren't quite dexterous. And we know that a poorly collected swab gives you the risk of having a false negative result. So we had a bit of QA happening in the lab. So we've got a delightful AO that looks at all of our specimens that come in. And if they didn't have any brown on them, they got sat to the side. And infection control were contacted to say, Mr. Smith in Ward X has got a swab that just looks like an air swing. So then we would chase it up and get a secondary sample from that patient. And it's challenging. So Catherine Watson, one of the other clinical nurse consultants, wrote a little ditty that pretty much said that the cotton tip needs to enter the rectum, just about 2 centimetres. Please don't make the eyes water. Gently rotate, and then pop it off. And the presence of faecal matter means that it's a good indication of an appropriately collected specimen. You wouldn't think you'd need to do that, but sometimes you do. Because getting a really good specimen is key, A, for the lab, you don't want to waste your money, and time of the laboratory staff, but you really want to avoid having that false negative result. So I guess other things that we did in the meantime was we shared the love right across Queensland. So we did let people know, which was important, and Graham was instrumental in maybe letting different groups know. So we then had a case at the Mater, a case at QE2, case at Logan, case at Redlands, case at Ipswich. All of these patients, of course, had been to the dirty PA. So then it became a multi-institutional investigation, I suppose. We shared the resources. Patrick's team did sequencing on all of them to make sure that they were all looking exactly the same. And how many people in the room get curry alerts? Pretty much everyone should, I would assume. And you would have seen at that point, Queensland just completely blew out in the curry alerting system. Something to be proud of, I'm sure. And of course, the key point, as Graham said before, was actually sharing what it looked like from a lab perspective early with all of the other sites and all of the other laboratory groups as a bit of a note point. Because we did share a lot of patients. We had even phone calls from Melbourne and Sydney where patients had gone on holidays and presented that they wanted to know, was this patient involved in our outbreak?
Just to add to that, so another useful thing was, so obviously there are Oxford 48s elsewhere in Victoria and New South Wales. So we were actually quickly able to send our genomes down to NDU and Melbourne, for instance, and they could compare to their known strains and where this was something new. So again, that's a very great advantage of having the genomics. It's very portable and you can compare across jurisdictions. Now, ultimately, I guess we'd love to have like a national database where this sort of happens in real time. Maybe one day we'll get there, but at the moment it's more of a kind of ad hoc,
Absolutely. And I can tell you, I'd not heard of Oxford 48 or 181 prior. Now I'll never ever forget it, but I certainly didn't know about it beforehand. So I suppose D-Day, biggest D-Day for us was the 2nd of June, and that's where we screened the whole patient population of the hospital. So it didn't just impact on us, it also impacted upon the laboratory and the staffing requirements. We did have a big focus on our transplant unit, our ICU, renal, spinal, rehab and ID, and then we just continued to screen. Lots of environmental screening, particular focus on cleaning still, enhanced presence from us. So I don't actually think we did too much more during that time apart from focus on the outbreak. And then we had a great executive response in terms of outbreak management team. So our environmental screening was really led by Margaret Lindsay as our infection control scientist, and we got downright and dirty, I suppose, wandering around trying to isolate this particular organism. And I guess, as everyone's highlighted, the methodology around environmental screening is really challenging because there's not a lot written and it's not really clearly articulated. But we went along and we collected 92 environmental screens. We focused on the high-touch areas of patients' rooms that were known to have a colonised patient in them, as well as patients that were known to be negative. And we actually only found 2 positive samples, both of which were from a patient who was known to be colonised. One was the toilet bowl. Naomi Runniger would have actually had us dismantle the toilet if she could have got us to do that. And we also the overbed table, and it's well recorded in the literature. All of Stephanie Dounce's stuff talks about that lip on the overbed table, so we clean really well on the top, but we don't clean well underneath, and that's where you grab to pull it towards you. So we didn't find anything too exciting in that space when it came to the environmental screening. And I don't actually know whether we sent that for sequencing. We did, didn't we? And it was the same, wasn't it? Perfect. Phew.
In the crap out rate, we didn't find screening in the rooms of patients with known colonisation like this, but I think we did do a little bit of it in room 1 and 2, and we did find positive results. It's kind of a bit expected because the patient was in there with crap already. And it was in the toilet. And in the toilet of the room that the patient was in already with that sort of non-contributory. So I guess we were looking for more shared points of what's happening.
We did all the shared points and we didn't find much at all, which was a little bit challenging and disappointing. So I think this next bit's yours, Patrick.
Oh, look, this was just, I guess this was just to make the point that, again, having that sort of liaison with the laboratory is really useful. And, you know, we accumulated, I guess, our strategy to how to deal with these organisms in the lab. And we found basically that the MICs were all over the place. They could be anything from completely susceptible to fully resistant. So you couldn't really use the MICs as a very reliable guide to pick these strains up. The beta-carba test was actually not that great, and quite a lot of these strains would not come up positive with the beta-carba test. But in fact, the only thing that was 100% reliable was this chromogenic media. So again, just having that kind of, just thinking from the laboratory point of view, how you're going to maybe modify your workflows for the particular strain you have, which you're targeting. So look, just to, I guess, to sort of put it all together at the end of the day, what did we get out of this in the final analysis? So I think there were over 1,600 screening swabs performed overall, and as Belinda said, nearly 100 environmental swabs. So from those, we actually grew over 100 isolates, including the patient and environmental samples, and all of these were sequenced. And 84 of these ultimately turned out to be the outbreak ST38 strain. And this involved 72 patients overall. So again, this is the sort of amazing thing about this is how 72 patients in a hospital can, go from a single patient to 72 patients all across the, not just at the PA, but multiple hospitals elsewhere, from inter-hospital transfers. So these things can really happen at quite a pace. And, we were really sort of playing catch-up, I think, right from the beginning. And again, it goes back to the point that if we'd probably let this fester for a few more months or maybe another year, the cat would have been out of the bag, and this would have been in the nursing homes and in the community and wherever. What we also found that was really interesting is we found some of these strains didn't look like an OXA 181 producer at all. They had a completely different antibiogram. There was no evidence of a carbapenemase, but there was still the outbreak strain. So that ST38 had lost its plasmid, so it had reverted back to a sort of boring old ESBL phenotype, but in fact was actually still part of the outbreak. So again, the genomics can kind of help put these things into context, even though the phenotype is quite different. And look, overall, this is, I guess, a sort of timeline to sort of put this into context. So this was when the first patient came to Vietnam. This is when we first noticed those cluster of 3 cases. Here was a cluster of 3 cases. Those were the 2 intermediary cases. And this is when we did all our sort of genomics. So it wasn't sort of in real time, but it was fairly close to real time. We were able to get results back to people in a fairly short period. This is when there was the intensive screening of the entire hospital, and obviously a lot of identification of organisms at that time. Then there was a second round of genomic testing as all of these isolates sort of came through the system. But the reassuring thing was actually quite quickly things started to after this massive intensive effort, things actually appeared to calm down quite quickly. And in fact, since that time, we've never seen this strain again. So it really did manage to somehow be sort of wiped off the face of the earth. Now, you never know. Maybe there are things circulating out there that we haven't seen yet, and it'll come back to bite us. But we've been sequencing a lot. We've sequenced nearly 2,000 genomes since this outbreak, and we haven't found it at all yet. And I guess you can kind of sort of retrospectively, but we were sort of building this picture in real time to really understand what actually was happening with each of these individual genomes. And you can actually start to piece together quite an interesting story. Again, looking at some of the subtleties in the genome to sort of understand the transmission. One thing I guess to say is that the vast majority of these, so over nearly 50 of these, including those 2 environmental isolates, were all completely identical at the core genome level. So they were clearly very, very closely related. But it's tricky when you have such identity, you can't really tell much apart. They all look exactly the same, and you can't really say anything about how they're related to each other, except they're all the same. But when you start to accumulate SNPs or other variants in the genome, that's when you can start to get a clue of how these are transmitting between different patients. So, for instance, it was noted that, in fact, there was a cluster up here that all acquired a phage, and then, from that you can see the radiated out of from those organisms. You could see how they've actually acquired other plasmids. This one appeared to have lost its OXA 181 and its associated plasmid. This one had acquired greater resistance to carbapenem. This had acquired another plasmid. This one lost the OXA 181 and then transmitted to another patient. and so on. In fact, this one was really interesting. You can actually see the plasmid jumped into a Klebsiella pneumoniae, and that patient actually ended up having a bloodstream infection. So you can kind of, again, you wouldn't have expected that to be related, but when you look from the genomics point of view, you can start to trace how these things tie together. So although there were a huge number of patients colonised, interestingly, not that many patients became clinically infected, and I guess this is sort of the tip of the iceberg thing. But there were a couple of patients that had bloodstream infections. One patient did actually die. Had other comorbidities, but I'm sure it didn't help. As I said, we noticed this plasmid transfer of the OXO181 into other species that cause subsequent infections, and obviously this transfer of patients to other hospitals right across Queensland. So that was it. It was a huge effort, particularly a huge credit to the infection control team at the PA. I think did a pretty amazing job. But so far we haven't seen it again. And look, I don't know whether this is a too bold claim to make, but since we've been doing routine genomics, we haven't had any of these enormous outbreaks. Now, you know, cause and effect. But, you know, prior to this, about every year we were having something terrible going on, and so far we haven't. I don't know.